Hello and welcome to the third lecture of the glaciers part of JOS 119, 120. Today we're going to talk about glacier motion and ice flow, but first we will focus a bit on just do a reminder of the previous concepts we saw during the last lecture. So if you remember that graph that explains basically what keeps a glacier moving, on most glaciers, you have on the top of the glacier the accumulation area where the glacier is creating mass. So you have snow that's accumulating, transforming through time in firn and finally ice. And on the lower part of the glacier, you have the ablation area where the glacier is melting. So the main difference between the two areas is that if you consider the ice being created as an input and the ice melting as an output, in the accumulation area, the input is bigger than the output, and in the ablation area, the input is smaller than the output. So ablation area, it melts more, and accumulation area, you create more mass. The transition between those two areas is called the equilibrium line altitude, the ELA. The snow line is a bit different, but we will consider those to be the same for this part of the course. The snow line or the ELA is the part where there is as much accumulation as there is ablation. So basically the net mass balance is equal to 0. In the accumulation area, the net mass balance will be positive, and in the ablation area, the net mass balance will be negative. This is explained here through this in this drawing. We can go very fast, quickly, sorry. So accumulation area, we have that winter net mass balance, meaning how much snow is falling, what is the maximum amount of snow we have during winter. That's going to be our blue arrow here. And in summer, the summer balance is mostly melt, how much of the snow melts away in red. And the difference between those two arrows will give us the net mass balance throughout the entire year, which is the green arrow. If that net mass balance is positive, it means the glacier is growing. If that net mass balance is negative, as in the lower part of the drawing, then the glacier is losing mass. This is typically what it looks like in the accumulation area, and the lower part is what it looks like in the ablation area. So as we said during the last, I think it was the last slide of last lecture, there are 3 different possible scenarios for glaciers, and basically you can make the comparison with your bank account. You have some accumulation, which is the income, the mass of the glacier are the savings, and the ablation are the spendings. If the ELA is near the top of the glacier, it means the biggest area of the glacier is experiencing melt. Therefore, your net mass balance will be negative and your terminus of the glacier will retreat. If the ELA is close to the bottom of the glacier, it means most of the glacier is experiencing accumulation. So you have a net mass balance and the glacier is advancing. If the ELA is around the center of the glacier, it means that the area of the accumulation, the area of the ablation are mostly equal, and therefore you have a mass balance that is equal to 0, and the terminus stays at the same location. You have a glacier at equilibrium. We also reviewed some measuring techniques to calculate the mass balance by, for example, drilling snow probe by drilling stakes in the ice and measuring by how much they stick out at the end of the melt season or during the accumulation season. You can do snow pits to measure the density of the snowpack. And you can also measure the mass balance from satellites or planes by measuring how the height differences of the glacier surface in time. This is a small example of the measure of surface elevation, for example, between 1996 and 2000 and 1948 and 1996. So if we look at the bottom part of the glacier, we have outlines that are showing the surface of the glacier at different times. So 1948, 96, and 2000. As you can see, is that the glacier gets smaller in time. So what happens if you look at the ELA is that this elevation and this profile will change in time. As as you go higher up on the glacier, so imagine there's like a vertical line that's scanning through the glacier, then you will see that the surface elevation will change. It's not homogeneous, meaning that at the top of the glacier, you have no change in surface elevation. In the middle of the glacier, you have a lot of changes in surface from one period to another. And we can see here that the curve is basically at its minimum minus 600 feet, and that corresponds to the part of the glacier that experienced the most changes between 1948 and 96 and 2000. Now let's talk a bit about glacial flow lines. So this figure shows how ice travels in your glacier from a side view. So that's the bedrock. You basically cut your glacier in the middle and you look at a transversal view of it. Just a bit of vocabulary here. Englacial means within or inside the glacier. We can talk about englacial flow if you have some ice that's melting, it creates some flow, and if you look at a river, a melt river that's inside the glacier, then it's englacial. So if you put something at the top of the glacier, you will realize that it actually gets buried inside the glacier. Those lines, those dashed lines with arrows, represent how the ice moves through the glacier. The very interesting thing is that the higher you put something on the surface of the glacier, so at the top of the accumulation area, that is going to get buried and travel pretty deep within the glacier and finally re-emerge only at the terminus. Now, let's say you lose a GPS or something, a watch or a stake on the surface of the glacier close to the ELA, but in the accumulation area, then that will not be buried super quickly and stay really close to the surface, and therefore re-emerge pretty shortly after the ELA. So if you want something to stay in the glacier for a long time and re-emerge only at the terminus, you should bury it and put it on the surface of the glacier the highest as you can. So that's an important thing to remember, is that the closer you get to the ELA and the more on the surface the ice will travel and will stay close to the surface. So as just a small quiz preparation to make sure you understood that principle. So if a GPS station falls into a 5 meters deep crevasse in the ablation area, what will happen to it after it falls and where will it travel? So there are three options. It stays near the glacier surface and moves down the glacier. It moves vertically down until reaching the glacier's bed and then travels to the terminus, or it is buried deeper and deeper by snow accumulation. So the answer for that question is answer A. It stays near the glacier surface and moves down glacier. So why? Because we said the GPS fell into a crevasse that's 5 meters deep. It's not that deep, especially if you consider that your glacier is hundreds of meters thick. And on top of that, you know it's in the ablation area. So if we come back to the previous slide, it falls around here, so it will re-emerge pretty quickly. And it's not answer B because we said it falls into a 5 meter deep crevasse. The crevasse is never going to reach the bed of the glacier unless it's a moulin, and it's a different story, but we are talking about a crevasse in that case. And therefore, the station will not reach the glacier's bed and will not travel to the terminus, because if we look at the previous figure, everything that is buried or that is on the surface in the ablation area will not necessarily travel down glacier to the terminus. If you want something to emerge at the terminus, you have to bury it very high up on the glacier. And finally, it's not answer C because we are in the ablation area, so there's no snow accumulation by definition. That's what happens in very specific cases. So the correct answer is answer A. Another question: a rock falls onto the glacier surface near the top of the accumulation area and is buried by new snowfalls year after year. So you're high up on the glacier. Where would we expect to see this rock out of the ice after probably a very long time? Answer A, in a moulin. Answer B, on the glacier surface after it melts out near the ELA. C, never, it will stay near the glacier bed. or D, on the glacier surface near the terminus? So it's a bit of a tricky question, but the right answer for that one, I'll let you pause if you want. The right answer for this question is answer D, on the glacier surface near the terminus, next to the terminus. So it's not answer A because, well, we didn't say that the rock was falling in a moulin. It's not answer B because if it falls high up on the accumulation area, it's going to travel deep into the glacier and it will not it will not resurface close to the ELA. If we come back here again, that would be that kind of case where you bury it very low on the accumulation area and close to the ELA. Never it will stay near the glacier bed. There's no reason for that to happen. I don't see why. If it's in the ice, then it's gonna emerge at some point. And D, it's on the glacier surface near the terminus. So as we said, we buried our rock high up in the accumulation area. It travels deep within the glacier and resurfaces next to the terminus. That follows exactly that path here, the deepest path that I described, showed by this dashed line and by my mouse, if you can see it. And that's the end for this section. We'll talk about the rest in the other video.